Okay, today we'll look at line number 3 in the policy gradient proof in the ongoing series of the understanding policy gradient proof. Okay, so here's the line 3 in the context of the policy gradient proof. Here you can see it in the context of the previous line that we proved last time. So we want to go from here to number 3. So starting where we left off with line number 2, here's what we want to prove. We want to prove that the sum of this term is equal to the sum of this term. The only difference being here, you can see that the last term is expanded. And to do this, first, let's put our goal at the top here. So what we want to do here is basically we want to expand this q pi as a term. And to expand this term, first we need to solve an exercise. So the exercise in question is exercise 3.19. And let's read this over. What it says is the value of an action q pi s of a depends on the expected next reward and the expected sum of the remaining rewards. Again, we can think of this in terms of a small backup diagram, this one rooted at an action, state-action pair, and branching to the possible next states. So in other words, what it's saying is that the value of this depends on this r and the expected sum of the remaining rewards, which is basically what value of s. Next, it goes on to say, give the equation corresponding to this intuition and diagram for the action value q pi s a in terms of the expected next reward r t plus 1, so it's the expectation of this, and the expected next state value, so this is the expectation of this, v s t plus 1, given that we start in state s with an action a. This equation should include an expectation, but not one conditioned on following the policy. In other words, the expectation that we're looking for should not have the policy term in it. Then, give a second equation, writing out the expected value explicitly in terms of the dynamics function p, s prime r, s, and a, such that no expected value notation appears in the equation. So as you can see, this exercise has two parts. Let's deal with the first part of the question first. So this is the first part of the question. Let's look at the diagram here. Suppose we chose this action A in state S. Then we can average rewards and values of value function. The resulting reward will be expected reward here, and resulting value will be expected value of the next state. So if you see, this gives us the first part. Then the second part, we need to get rid of the expected value, writing out the expected value explicitly in terms of the dynamics function p. So the expectation can be expanded by using probability, which our environment tells us what the probability of it is. So if we take action A in state S, the dynamics function p tells us what is the probability of transitioning to S prime and receiving reward R. So expanding this, we get the probability of taking this particular branch here, which is R plus V pi of S prime. So you can think of this as the sum over all of these, where each branch is multiplied by the probability of going in that direction. And this is simply the definition of the expected value. And so we have expanded this term q following these two steps of this question. First, looking at the diagram and phrasing this in terms of the expectation, and then writing out the expected value as a sum using the dynamics function p. Let's move what we just showed in parts 1 and 2 to the top. What it says is the action value function of state S given the action A is just the sum over all the possible branches that we can take, multiplied by the probability of going in that branch, P R S prime given SA, times the actual value of that branch, which is the sum of the immediate reward and the expected next reward. Now, let's put what we want to prove at the top again. And clearly what we need to do here is expand that q term using the exercise we just did. So let's do it, starting with the original equation here. and substituting the result of exercise 3.19, this is what we get at the bottom. And now it's clear that the right side of what we needed to prove and the right side of what we got is the same. So therefore our proof is done. So I hope you enjoyed this part of the proof. Relatively straightforward. Enjoy the rest of your day.